Let's start with the name of Allah, which is the entirely merciful and especially merciful. Today we are going to discuss about the WKB approximation method. This topic is from Griffiths book, chapter number 8. WKB approximation method consist of three things: WKB, and then approximation, and then method. WKB is stand for Wenzel, K for Kramer, and B is Brillion. These three physicists was introduced the WKB approximation method. Approximation mean not accurate. Method mean techniques. So these are the combination of three words. Now what is the WKB approximation method? So statement of WKB approximation method is: it is a technique which we can used to obtain the approximate solution of time independent Schrödinger wave equation. The second thing is to calculate bound state energy. The bound state energy. The third thing is to calculate tunneling rates. This is a statement of WKB approximation method. WKB approximation method it's a technique which is used to obtain the approximate solution of time independent Schrödinger wave equation. Second thing is to calculate the bound state energy. The third thing is to calculate the tunneling rates. So this is a statement of WKB approximation method. This method is used to calculate the time independent Schrödinger equation for one dimension. We will consider a particle which is moving in x direction. Imagine a particle, or consider a particle which is moving in x direction, having energy E is greater than potential in a region. So the wave function of this system will be psi of x is equal to a exponential to the power iota kx plus minus. Plus sign indicates the particle is traveling to the right negative sign show particle is traveling to the left side. The energy, we know that energy is equal to p square divided by 2m plus v. Here we know that momentum is equal to h cut k. So this potential energy subtract from both sides, so we will get E minus V is equal to P square divided by 2m, multiplying both sides the 2m, so we will get P square is equal to 2m into E minus V square root, taking square root both sides, this will be cancelled. So P is equal to 2m into E minus V square root. This equation is for momentum. This is a wkb approximation method. It is a technique which we can use to obtain the approximate solution of time-independent Schrodinger wave equation for one dimension, to calculate the bound state energy, to calculate tunneling rates. We will consider a particle which is moving in x direction, having energy is greater than potential in a region. So the wave function for this system will be psi of x is equal to a exponentially power plus minus iota kx. Plus sign indicates the particle is traveling to the right. Minus sign show the particle is traveling into the left side. So the energy will be equal to p square divided by 2m plus v. P momentum is equal to h cut k, and the p momentum will be equal to 2m into e minus v square root. Now instead of momentum p, we will put p is equal to h cut k, and we know that p is equal to 2m into e minus v square root. Instead of this p, we will put h cut k is equal to 2m into e minus v square root. Dividing both sides the h cut, k will be equal to 2m into e minus v square root divided by h cut. This is a first part of WKB approximation method.